When you hear the word deforestation, what pops into your head? Probably chainsaws, right? Falling trees, vast stretches of cleared land. And yeah, that's a powerful, devastating image. But in this explainer, we're going to look past what our eyes can see. Because the most critical story of deforestation, it's happening where we can't see it at all. Okay, so let's just dive right in. We all see the destruction on the ground, but the real question, the one we're going to tackle here, is what are the invisible consequences? What's unfolding high above the forest floor? The answer is literally changing how we understand our planet. And that's because the biggest dangers, well, they're taking root way up high in the atmosphere. We are talking about fundamental changes to the very air itself, all triggered by what's happening on the ground. So that brings us to our first unseen threat, and it is a big one. The sky is literally drying out. Now, to really get how this is possible, we first need to understand how the Amazon basically makes its own weather. It all comes down to this incredible process called evapotranspiration. I know, that's a mouthful, but stick with me. It's actually pretty simple. Just think of the entire Amazon rainforest as one single massive engine. It sucks water up from the ground and then breathes it out into the air as water vapor. This process is so powerful that it actually creates more than a third of the Amazon's own rainfall. The forest literally waters itself. So what happens when we start breaking that engine? Well, it kicks off this whole chain reaction. First, obviously, the trees are cut down. Simple enough. Second, that means way less moisture. It's getting recycled up into the atmosphere. The air starts getting drier. Third, the cleared land gets baked by the sun, causing hot, dry air to rise. And finally, and this is the absolute kicker, that rising column of hot air acts like a giant wall. It physically blocks the moist air that should be flowing in from the Atlantic. So not only can the forest not water itself anymore, but it's also being starved of water from the outside. And look, don't just take my word for it. This is how the researchers put it. The drying is so severe that it cannot be compensated by enhanced water supplies from the Atlantic Ocean. Let that sink in. This isn't just a temporary dry spell. What we're seeing is evidence of a potentially irreversible shift in the Amazon's entire water system. So how close are we to that irreversible transition? Well, in just the last 50 years, we've already lost 17% of the Amazon. 17%. That's a staggering amount of that giant self-watering engine that's been shut down for good. And that 17% figure, man, that is scarily close to what scientists call the tipping point. The theory goes that if deforestation hits somewhere between 20 to 25%, the whole water cycle could just collapse. The rainforest would no longer be able to sustain itself, and it could flip, transforming into a much drier, savanna-like ecosystem. Okay, let's switch gears to our second unseen threat, and this one is a real scientific puzzle. It all boils down to a seemingly simple question. When you cut down a forest, does it get hotter? Sounds easy, right? Well, the answer turns out to be it totally depends on what and where you measure. And this is where it gets really fascinating. Scientists look at temperature in two main ways. First, there's surface temperature, what you'd feel if you touch the ground. They call that T-surf. Then there's near-surface air temperature, the air you're actually standing in, about 2 meters up. They call that T2M. Now you'd think they'd tell the same story, right? Turns out, not even close. Okay, take a look at this. This map shows the change in surface temperature, T-surf. It's basically what a satellite sees when it looks down. And wow, look at those red areas. It's super clear. Where forests are cleared, the ground itself gets way, way hotter. No big surprise there. But now, look at this. This is the air temperature measured by weather stations just above that very same ground. See the difference? The warming effect is, well, it's tiny. It's far, far weaker. In a lot of places, it even looks like there's a slight cooling. So what on earth is going on? Why the huge difference between the ground and the air just a few feet above it? Well, the answer is all about the physics of day and night. During the day, that bare ground gets baked by the sun. This heat creates turbulence. You know, that shimmering heat you see rising off a hot road. That turbulence actually stirs things up, mixing cooler air from higher up down towards the surface. That can weaken or even cancel out the warming you feel in the air. But at night, the total opposite happens. The ground radiates all its heat away and cools down super fast. The air right above it just sits there like a calm, stable blanket, and its temperature just follows the ground right down, showing a much stronger cooling effect. This whole measurement puzzle gets even trickier when we zoom out, because the effects of deforestation aren't just felt right where the clear cutting happens. we have to make a really important distinction between what happens locally versus what happens globally. And these two maps show the difference just perfectly. On the left, you've got the local effects, that really intense warming of the ground that only happens right where the trees were cut. But on the right, that's the non-local effect. It's a much broader, much more subtle pattern that ripples out across the entire planet as the whole atmosphere adjusts. So let's just break this down real quick. The local effects, they're super intense right at the surface, but much weaker in the air. This is what matters to, say, a farmer who's dealing with heat stress on their crops. The non-local effects, on the other hand, they impact the surface and the air pretty much equally. And this is the stuff that matters for big-picture global climate policy. Two different effects needing two completely different measurements. Now, I know this might sound like we're getting lost in the weeds here, but I promise you, this isn't just an academic debate. Figuring out which temperature to measure and where is absolutely critical. It's the thread that connects our two unseen threats, the drying sky and this whole measurement puzzle. Getting this science right is crucial for really practical reasons. Think about it. A farmer in the Amazon needs to know the surface temperature to figure out how to adapt, how to save their farm. But a policymaker at a global climate summit, they need to understand the non-local air temperature changes to create policies that actually work for the whole planet. If you use the wrong data for the problem, you're going to get a bad policy. It's that simple. So it all comes back to this. If we really want to prevent the Amazon's water cycle from collapsing, if we want to stop it from hitting that terrifying tipping point we talked about, then our actions have to be guided by accurate, well-understood data. We have to solve the measurement puzzle if we want to have any hope of solving the atmospheric drying crisis. And that leaves us with one final and pretty urgent question. The science is telling us loud and clear that the most dangerous effects of deforestation are the ones we can't easily see. So the challenge for all of us is, how do we make these invisible threats visible to the world before it's too late?